One cool thing about working in object orientation is it has its own language, if you will. It's called UML, the Unified Modeling Language. And so the great part about that is it's a shorthand that describes our software with some easy to construct pictures. And I say easy to construct, eventually easy to construct. It takes a little time to get used to them. But it's certainly less than having to write paragraphs and paragraphs and paragraphs and long flowcharts and all that sort of stuff. There's some really nice ways to do that. Now, we're going to just do an introduction here. We're just going to talk about some simple things that come up. But as you go and learn more about IT and programming and design, you'll learn about these tools. And this tool all relates to your code, and your code relates to these tools. And so you should hopefully every so often stop and reflect. Stop and think about how your code looks at the big picture and how you can maybe demonstrate this stuff to be able to help share this type of picture with other people. Because that's really the purpose of design, is to be social, to be interactive, to run your ideas about stuff. And UML is a great way to do that because it gives us a vocabulary of sorts to describe these things. And it does that by having all these different types of diagrams. Each diagram gives us a specific view to talk about a specific aspect of the system. So when I see this diagram in front of me, if I'm talking use cases, I know I'm not worried about detailed logic of it. I want to know what offerings am I giving to the users. We have class diagrams that tells us about the structure of our program, and sequence diagrams that tells us about some specific flow. Collaboration diagrams, much the same. Each of these diagrams tells its own stories and shows data in its own way. And we're not going to talk about all these here in this class for sure. We've got plenty of other stuff to talk about. You'll learn about many of them, in the different classes you'll take over your learning here, you get your degree. But each of these play a different role within the system. Really the one that we're focused on for now is the use case diagram. A use case has this diagram, but it's more than the diagram. A use case itself is a description of some service our software is offering to another user. A user typically is a person, but it could be another system. We could offer a service out there such as PayPal, which allows other websites to make payments for their users or whatnot. As a user, I might not see the PayPal site at all. It might be somebody else who provides those pages. But just the idea is there's some interaction. There's a series of inputs and responses, or maybe just a single input and response that we're going to describe. But typically, a use case is a person sitting down at a keyboard and mouse, or a screen for a phone with fingertip presses, that gives them some valuable business event. So you'll often see login as a use case. It's not a very valuable use case. The company doesn't make any money off of you logging in. You don't really get any value about logging in. But it's something that's just easy to describe in that. So think about something more useful, like depositing a check, or buying an insurance policy, or making a trade in a fantasy football team. And so it's going to show a flow of data, and it's going to show the rules that need to be followed in order to get that flow of data to happen. So a use case diagram is not any sort of details about how those things happen. The use case itself tells that story through text. There's a document that talks about the flow and everything. The idea of a use case diagram is to show you at a high level kind of the menu of service offerings that are out there for people to take advantage of. So when I go into a restaurant, I don't see how they scramble my eggs. I just know that they offer scrambled eggs. They also offer pancakes, and they offer gyro. They offer you name it. There's all sorts of stuff on the menu. That's what a use case is like. My system will allow you to deposit checks. My system will allow you to withdraw funds. My system is going to allow you to check your balance. My system is going to allow you to buy an insurance policy, make a claim. High-level features. There's no indication of the order the user uses those in. And there's certain assumptions I don't make. Like, of course I'm going to log in before I deposit funds. It's just a prerequisite, something that's given as part of the details. I'm not showing that much detail. So I'm throwing out use case off the top of my head like crazy, but how do we capture this stuff typically? Well, there's a document with a template that describes the behavior for most of the details you typically would see in a flowchart. That's the place where you talk about, again, cracking the eggs, putting the bowl, all those details we talked about there. That primary flow is what the user does to interact with the system. It tells us all the trick and the the tricks of the rules of how those things are supposed to happen. If there's an absolute requirement that the pan must be 400 degrees before you start to fry the egg, well, put that in there in that document. And that's a whole art and science of its own to figure that stuff out. What we care about in this class is the use case diagram. And what we want to capture, what we want to see is at a high level, what are the things the system can use? Now, the application we build will do basically one thing for the most part. It's going to order a pizza or whatever you plan to order. So at this point, you get to use your imagination. What else would you have the system do? So maybe I can rate my pizza online to say how good or bad it is. Maybe I can join a frequent pizza eater club and be able to get new free pizzas after a certain number of times. Maybe I can upload Instagram photos of my pizza to show how great it is and get points to it for doing it that way. All this sorts of high-level features, again, doesn't say how it works. I'm not telling you the steps of what's happening in a pizza in the diagram. I'm telling you what are the offerings. And so the offerings come from whatever you think adds business value to the user. And again, business value, not just some little micro step that's going to happen. So after talking about them, let's look at a use case diagram. Right here is the use case that we built already, cook breakfast. Now, in our case, we had very specific instructions. The breakfast might mean, in this case, you have scrambled eggs. That's the only breakfast that's offered. There could also be some choices involved. There could be, do you want eggs or do you want cereal? That's okay. We don't care about that. What we want to know is who's doing the work, the actor, the stick figure off to the side here. We have the chef here. And then what are the things that chef is allowed to access? And the line tells us the chef can go into this boundary area, which might be as the kitchen, might be as the restaurant itself. Who knows what the boundary is? And can access these features. Now, in this case, there's one feature being shown. That's not typical. There's normally a lot of them. It's just simplified here to show you the three main pieces we care about in use cases. The actors, which are stick figures. The use cases themselves, which are these little ovals, the bubbles out there. And then there's the boundaries, which are the square boxes, which talk about the domain. Now, there could be multiple domains. Maybe the chef is allowed to cook at the restaurant, but is not allowed to cook at home because you're under contract. You can only cook for me in the restaurant, and you can't cook at home. So that is the use case diagram in a nutshell. That's what you're going to be asked to do. We talk about classes a lot, and classes are the quintessential core of object-oriented systems. So class diagrams basically show what are all the different pieces. In the system we had before, we had some nice pretty pictures. Well, in UML, we use them as boxes. We have an egg, a bowl, a pan, a plate. At the simplest, this is a class diagram. It shows the 4 different classes that are part of the system. It's the truth, the foundation, the structural core of the static architecture of my system. These are the pieces I'm going to create, the code I'm going to write that will always exist. Now, this doesn't tell me a lot of information. So the real class diagram starts to look a little bit more like this. A class has a box, but inside there's compartments. This top compartment, the first one on that, and typically there's 3, is the class name. Then there's a little compartment in the middle. I mean, it can be a big compartment, actually. In this case, there's just one. But this is where the attributes go. This is the data. This is what the class knows. So an egg has a yolk and a white. The bowl has whatever contents are inside of it. All those things are the different pieces that the class knows about, the data that it stores. And then the bottom compartment there is its methods. That's the stuff it does. You'll learn about constructors that are on there used to build objects. But this is the work that this class can do. Sometimes there's a 4th compartment that talks about events. That's very rare. Most languages don't have a specific event around that, but it exists in UML. But this is the class diagram, the core of the class diagram inside of there. Now, a few notes that it's really important to understand about object-oriented UML diagrams is class names should be named after the thing it's representing. Again, bowl, egg, plate, pan. Notice it's tying to the quote-unquote business here, the system that's being done, the real-world stuff, and it should resemble whatever the organization calls it. So if you read a document that says, we refer to eggs as huevos, because they're a Southwestern restaurant, then you should be referring to that in code by huevos instead of eggs, because that will make your code more closely relate to the work that's being asked for, make it easier for people to review your diagrams in your code, and easier to understand later on when people are making changes and they say, oh, yeah, this relates to this thing. Most importantly as well, the class should start with a capital letter. All classes should start with capital P pan, capital E egg. And we'll see what's called camel case later on, where every word in the class, if it has more than one name, also is capitalized. This becomes really important in Java because stylistically, if you see a capital letter, you should be expecting a class to be part of that. And it makes reading and comprehending that much quicker because you just immediately know what things mean when you see them. Now, attributes are part of the class that describe that class. So if we wanted to describe an egg, we could talk about the size of the egg. Is it a medium, large, or jumbo egg? We could basically use it to describe. So it's use a student. You have a first name, you have a last name, you have a student ID, you have a GPA, you have the courses you're registered for. Those are ways of describing you. This is the way of customizing one object over another object when you start talking about the real-time system, the work that's happening in the system. They tell us more information about the objects. And then you have the methods, which is what the objects do. That's, again, methods are equivalent to procedures or functions. It is the behavioral aspect of the class. So it is things I can ask that class, that object, to do. It provides data updates to the class. It retrieves data from the class. It does the work of the class that's going on. The relationships then between objects tell us which objects keep track of which other objects. In this example, I have a miner or a construction worker or something like that, and that person keeps track of their tools. So that wheelbarrow belongs to this worker right here. It's not yours, it's not mine. Without this wheelbarrow, this shovel, this pick, this miner can't do their work. Without the miner, this wheelbarrow, the shovel, the pick just lie around and they don't do anything. So relationships are there to talk about key system pieces that must coexist in order to get the most functionality, or sometimes any functionality, out of them. If I tell the miner to go into the mine without their tools, digging with their bare hands isn't going to do much work. And so in UML, in the class diagram, the relationship is drawn as a line between these classes. And we go back to that original one we had, that little tiny one. In this case, we have the miner, which is the owner of tools. So that's what this right here means. They have either 0 or 1 owner, the tool does, and that's the miner. And the miner owns star number of tools, star being 0 or more. And so the line tells us which objects keep track of which other objects, and the relationship on that line helps us furthermore know who keeps track of it. In this case, they keep track of each other, but perhaps the tool doesn't care who owns it. It might not care. It just depends. If I want to put a label on a tool, I can. If I want the tool to be owned by anybody who uses it, I can do that as well. So the beautiful thing about UML is, you can see from this diagram, I don't have to show everything all the time. The miner has methods. The miner has attributes. The tool has methods and attributes. In this picture, I'm showing you a specific view. I just want you to see the relationship. I don't have to show you everything all the time to get confused in all the details. So there's a lot of flexibility in UML. So for your purposes, draw diagrams that tell the story you want them to tell, but draw them accurately. When it asks for ovals, use ovals. Don't use squares. Don't use triangles. Don't use bubbles. When it asks for class diagrams, these rectangles, use the rectangles. Use the components appropriately. We'll talk more about that as we go, how to draw them, how to make that happen. But for now, just know that this is the structure that you want to go off and do. Spend some time playing with this. Build your diagrams and get feedback. You're not going to get it right the first time. This is something where it takes some practice. You got to do it a couple times. I mean, I remember when I first started learning this stuff, sitting down at dinner with the instructor specifically so I could work over my stuff and get it right. And I was so disappointed I didn't get it right the first time. But that's what this stuff is. It's about refining your understanding. It's about understanding how to best use these tools, and the only way to do that is practice it. So let's take some time, we'll draw some UML, and then learn from that, because that's a key feature going back and forth between coding and design, and that's where you really start to get a better understanding of each of them.